So I alluded to it before. Now we're going to talk about it a little bit more. So far, everything we've done has been less than, and we did this one between that we were looking at. However, whenever we're talking, remember, what are all the same words? If this is talking about the area, what else do we know that means? Proportion, probability. I'm going to keep beating that same drum over and over again because I want you to really get it. Now, something else we can do with this is you can look at a table 5 and work through it. We're not going to do that. We are going to use technology. And our technology for this is going to be StatCrunch. All right. We are going to use StatCrunch. All right, we're going to use, oh my gosh, I can't tell that's the word crunch. I don't know how you can. Oh, for crying out loud in a bucket. Crunch. Oh, that's so much nicer. Okay, we're going to use StatCrunch for all of this. And I've shown you how, but we're going to make it even more obvious because we're going to do a couple more examples here. All right, so if you find the area left, I know that this is going to be less than, right? Whatever that value is. To the right, this is going to be greater than whatever that value is, all right? And that would be not what my z-score automatically gives you. It would be the complement is really what we're going for there. So that gives you the complement to the right. Or if I'm going between these two, so I have something is less than or equal to x, which is less than or equal to something else. That's between those two, because this is what's actually happening. I'm saying I'm going to take my first big value, and we know that that's the area to the left. Then I'm going to take this small value area and subtract it. That's what leaves what's in the middle. So that's technically what's happening there is I'm subtracting those two areas so that I can get what's actually in the middle. But we're also looking at StatCrunch and doing our probability between those. All right, but I do want you to understand where these values are coming from and what that means, because we know area is the same as probability, is the same as proportion under the normal curve. Okay. So let's throw another P word in there. If I'm looking at this P word, it says the heights, so we're still on the same example, of the pediatrician's 3-year-old females are approximately normally distributed with this same mean and this same standard deviation. So we're down with all that. Find the height at the 20th percentile. There's another P word, all right? That's the P word that we're looking at. Now what this P word represents, if I'm looking at this, this means the 20th percentile. Let me, oops, I hit the wrong button. This 20th percentile here, I meant to hit this shader. That means that my area is 0.2. So it's kind of like it's going backwards, right? I don't have the value. That's what we're trying to find. Find the height. That is my x. That's what we're trying to find here, all right? Okay, so that tells me that I am going backwards with it. I want that x value here where I'm given the probability, the proportion, the area. The percentile is another P word that we go through, all right? So what we're really trying to figure out is what is my x value. So I want to find the probability that x here is less than, because remember we talked about percentiles already. Percentile is always less than. See, previous information into the current lesson. It always comes up. So that percentile is less than, so x here is less than what? And that equals 0.20 or just 0.2, right? Because we don't need that extra 0 there. And we still have the mean. We still have the standard deviation. So we're going to use the same piece here with the mean and the standard deviation. Remember how we get there? Stat, calculator, normal. And that's what pulls this up. But I'm just going to keep it up here because it already has my mean and standard deviation. So remember we said is less than some value that I don't know. And I know my area though, because my area is 0.2. That is the proportion. That is a probability. That is a percentile. Okay. And that's where we're going. So we're saying what data value, what is the height that's going to be the answer of area is 20. Based on this mean and standard deviation, my height is, we're just going to take this to 2 decimal places, 36.05. Do you see that? I'm going to pull this out up here. We'll scoot it over a little bit more, I guess. Maybe try to scoot this over. I was hoping to get both of them on the screen at the same time. So maybe. So I'm going to scoot this over. The probability that x is less than or equal to, here is that value of 36.05 is equal to 0.2. So what my question is really saying is therefore 36.05 inches is in the 20th, oh, sorry, I got that thing on there, percentile. So right here, this x value is 36.05. That is that x value that up to that 36.05, that's going to put you in the 20th percentile for height. Okay? Okay. That's what it is. So we can figure out what if we're given the x value here, this data value, if we are given the percentile, if we're given the area, if we're given the proportion, we can always figure out those data values using the same thing. All right, let's do a whole new problem. Scoot this over so we can see the whole thing. Oops, scoot it on up. All right, the scores earned on the mathematics portion of the SAT, which is a college entrance exam, we're familiar, right? Are approximately normally distributed, that's always good to know, with a mean of 516 and a standard deviation of 116. What scores separate the middle 90% of test takers from the bottom and top 5%? In other words, find the 5th and the 95th percentiles. So what this is really saying, I think pictures are nice. I'm not very good at drawing them, but I like to see what's going on. So this is my middle 90%. This is the top 5%, which just changing that to a decimal, right? 5th percent, 95th percent. This is the bottom 5%. So what we are trying to find is this bottom 5% and this top 5%, which means this number is what we're trying to figure out, and this SAT score value is what we're trying to figure out. All right? Okay, so I'm going to call this X1 and I'm going to call this X2. So when we go to plug this in, we have our mean, we have our standard deviation, and then if I'm talking about percentiles, this is going to be the probability that X here is less than this X1 value, and that's what we're trying to find, and that is 0.05. For this one, we're going to say what's the probability that X here is greater than, this is to the right. This is the first opportunity that we've got to go to the right. And that's where my greater than symbol comes in of whatever value that is. And then that is going to equal the 0.95, right? Because I want to see what is happening with that 95th percentile. But it has to be greater than the 95th percentile. Okay, so we want to change this up. We want to have our mean be 516. We want to have our standard deviation 116. And we don't know what's happening here, but we know that the area is 0.05 for 5%. So the score here for the bottom part is 325.19. Now, when I talk about this standard deviation, or whenever I talk about scores, we just talk about the whole score, right? So if I'm looking at this, this is just going to give us a 325. So X1 here is going to be, oops, you can't see that, so that's what makes me awesome. X1 here is going to be 325. And then I'm going to come over here and figure out what X2 is, right? So that's this other side. All right, so this is not what we need. I want to say what is greater than. From here, oh, so this is, I want greater than the 5%, greater than the 5. Because that's greater than that 5%. So this is in the 95th percentile. If I was talking 95th percentile, then it would be everything going down below, but I want greater than, and just in this top 5%. Do you see what's happening there? Yeah, so the 95th percentile is this top 5%, so greater than the top 5%, and that's going to put me at 706.8, so I'm going to round that to 707. Do you see what happened there? Okay, let me scoot this over. And I just looked at my sheet. I put it so you can see that. And I did put, I was talking 95 and I wrote 95. Do you see that this is 0.05 because of this greater than symbol? So X2 here is going to be what? 707. So that means, right, if we're looking at this, if a student, let's write this out in words. You see that whole thing? Let's get this whole thing over. If a student scores 325 on the SAT, they are in the 5th percentile. If a student scores 707 on the SAT, they are in the 95th percentile. Because just oh, dang it, percentile. Because remember, here's the deal. If I'm looking back through here, so this is my 707, and then this is still 325. A percentile is what it is and lower, regardless of the amount that we're looking. So this is still top 5%, but that makes it a 95th percentile. Because anytime I use the word percentile, I'm always talking to the left. So instead of saying the top 5%, which you can do, but that's the 95th percentile. The 5th percentile is the bottom 5%. So if you score up to a 325, then you're in the top 5%, or the bottom 5%. I'm sorry, I said that wrong. If you score 707, then you are right here is the 95th percentile. Higher than that could be even higher, right? Higher in on the percentile rank. Okay. All right. That's how that kind of plays out with that percentile, proportion, probability, looking at those values. That's what we're going for. All right. All right. All right.